Okay, so a scatter plot shows the relationship between a set of data that has two variables, right? So, for example, it could be like time and I don't know, like infection rate, whatever, right? It could be anything. Now, scatter plots are used to investigate a relationship between two quantities. They can have a positive correlation, a negative correlation, or no correlation. So take a look at this first data here, right? Um, like you have the lines here, you have the dots here, right? Plotted. And even though they're not in a straight line, you can see there is definitely a positive correlation. Like as this axis moves up, the y values are also going up, right? And then in this one, you can see that there is clearly a negative slope or a negative correlation. Here, do you see the difference? There is absolutely no correlation. There is no trend, okay? So look at this one. Determine whether the graph shows a positive, negative, or no correlation. If there is positive or negative correlation, describe the meaning in the situation. So clearly here, there is a positive correlation, right? Which means um, as the hours increase, the wages increase. Okay. So, like we said, scatter plots can show if there is a trend in the set of data. And in the case where the the points, right, all lie close to a line, we can draw what we call a line of fit, right? Which is something that can model the trend. So, for example, if I choose well enough 2 points, I can draw a line that goes through pretty much all of the points, right? That is like centrally located in all of the points. And because now this is a line, I can find the slope of the line and I can find an equation of the line, which means I can use that equation of the line to now extrapolate or to predict a value in the future. Does that make sense? Okay. All right. So that's what we're going to do right now. How do we do this? Well, once you make a scatter plot, you determine whether there is a relationship. If there is a relationship, a positive or a negative correlation, you want to draw a line that seems to pass close to most of the data points. There is a little bit of eyeballing that we're going to do, but for the most part, you can get it pretty accurate. We're going to use 2 points on the line of fit to write an equation for the line, and then we're going to use that to make predictions. So take a look here. The table shows the largest vertical drops of 9 roller coasters in the United States and the number of years after 1988 they were opened. Identify the independent and the dependent variables. Is there a relationship? And if so, we're going to predict a vertical drop 30 years after. So take a look. This is the years since 1988. So 1 year after, this was the vertical drop. 8 years after, there was one with 200 feet vertical drop. Okay. So which one of these is the independent variable? The years. This is the independent variable, and then this is the dependent variable. Knowing that tells us that the independent variable is going to go on the horizontal axis. This is going to be years, and then this is going to be the vertical drop in feet. All right. Okay, so let's go ahead and put these points here. One, we're at 151, so right there. Two, no, three, we're at 155, very close. right? So these are like super close. And then 5, we're at 225. That's right in the middle. And then what else? 8, we're at 230. 12, we're at 306 and 300. So 12, there is one at 300. There is one very close at 306. And then there is a 255. 13, there is another 255. 15, there is a 400. Okay, so you can tell there is definitely a positive correlation here. Now, what I want to do is I want to pick 2 points and draw a line. And I want the line to be such that it passes through or in the middle of most of them. So you know what I'm going to do? I think I'm going to take this and this point, right, the bottom point, and I'm going to take my ruler and I'm going to draw a line in between those two.
The bottom or the top one of it?
The bottom. Okay, so do you see how like it goes through like right pretty much the middle? So the points I picked are 3, 155 and 12, 300. Okay, so now what I want to do is I want to find the slope. Okay, so that's 145 over 9, 16.1. And then I'm going to use, I can use any of them. I'm just going to use the second one. Y minus 300 is equal to 16.1 x minus 12. Why did I use that one? Just because. So let's solve and put it in mx plus b form. So that'll be 16.1x minus 193.2. I add 300 and I get 16.1x plus 106.8. So this is my line of best fit. Okay? Now, what I want is predict the vertical drop 30 years after. So what I want is y of 30 is equal to 16.1 of 30 plus 106.8. Y of 30 will be 589.8 feet. Okay? So if this trend continues, you're like, man, 30 years from now, they're going to have a roller coaster with a 590-foot drop, right? Yeah. Okay, take a look at this one. The table shows, so here, the table shows the median age. I think this should say median age. Okay. The median age of females when they were first married, right? From 1996 to 2006. Make a scatter plot and determine what relationship exists. Identify the independent and the dependent variables.
What did I do?
Okay. Yeah. So, okay. So look, what we want to do here, right? What is also important when you're doing these is determine if there are any outliers. Okay? We also want to do that. So how many are there over here? 11. So let's see. Q2 is this one, this the last 25.1. Q1 is the 25. Q3 is the 25.3, the last one. So the interquartile range, yeah, 0.3. So 1.5 times 0.3 is how much? 0.45. So is there, 25.9 is an outlier. Okay, when so now when I do this, I'm gonna plot the outlier, but I'm not gonna use it in my scatter plot, in my line of best fit. Okay, so let's do this. Okay, so let's quickly graph this.
Wait, isn't it Q3 plus 145, which is...
Okay, so now that we know where the independent and the dependent variables are, right? We want to put that in there. So this is the year and this is the age. Oh, so that's the year and that's the age. And then do you see how we determined that this last point was an outlier, and you can clearly see that it is an outlier because it doesn't even follow the trend, right? That's kind of cool. So now we're gonna do a line that goes through these 2 points. So the way I do it is I kind of like put my ruler in between, and then I see which 2 points will lie on that. And just so we are all on the same page, I'm going to pick the point 2000 and at 2003. Okay, so we're gonna pick the points 2000 comma 25.1, 2003 25.3. Okay, so when we draw that, let me draw that, connecting those 2 points. Okay, here we go. Okay, so we drew a line of best fit. Write an equation in slope intercept form of this. So look, take a look at what I'm going to do. Instead of doing the 2000s, we know what I'm going to do. Since this is starting at 1996, okay. Okay, so here's what I'm going to do. M is equal to 25.3 minus 25.1 over 3. That's 0.07. And then y minus 25.1 is equal to 0.07. Let's just go ahead and use the whole point. Okay. When you solve this, you get y equals 0.07x minus 114.9. So predict, so that's C, right? That's part C. Predict the median age of females when they are first married in 2022. So now we're going to do y of 2022. Okay. And then you guys know how to plug that in. Do you think the equation can give a reasonable age for the year 2056? Well, my prediction would be no, because this is in 1996, right? That's when we start. And then in 2056, now it's 60 years after, and so much, this is like a whole generation different now, right? So like so much will have changed that I would say no. In that case, yeah, exactly. In that case, we would have to take new data and then, see that, right? And make a new model for that. So these are not like, all good for a whole lifetime. Like they're not good for like the lifetime of the planet, right? They're just good for like, a couple of decades at a time. All right? Okay, so that's that. And then this also has a worksheet. Let's go.